Hello everyone. We're going to continue with the intro to trigonometry. We've got a couple of more things to do, and then once these are done we can actually solve some problems straight through and through. So the first thing we have to do is we have to learn how to label triangles properly, or rather the sides of the triangle. And the second thing is we've got to take a look at this memory device, this thing called SOHCAHTOA. Helps remember what to do with all those sines, cosines, tangents, and remember cosecant, secant, and cotangent as well, should they come up. So let's take a look at the labeling first. When you're given a triangle, all the triangles we look at are going to have 90 degrees in them. Maybe later in life we'll change that, but for now that's what we got. Now, in the question there's going to be an angle of some sort that we are given info about, or else we got to find. Now, the location of this angle is very important because that is going to affect how we label the sides of the triangle. The side opposite the 90, that's the hypotenuse, always. The side that, and I might add, the hypotenuse is going to helps create whatever angle we're looking at or working with. The angle has the other side. This side here is called the adjacent side. Adjacent for besides. But they didn't want to say besides side because that would sound a bit confusing. So they say the adjacent side. So the hypotenuse and the adjacent side, these two make up the angle of interest, the angle we're working with. The last remaining side, that is the opposite side. Because just like you can sit opposite someone at the dinner table, this side here is opposite of this angle. Now, what could happen is the angle might be in a different location. Let's say, instead of having the angle at the bottom, as honestly it's often going to be just because of the way we set up problems in class and such, but in life not necessarily. So let's say the angle is up here instead. Well, how does that affect what the sides are going to be? Well, the long side, that is still the hypotenuse. That's not going to change. In fact, the 90 degrees points at it, if you like. Some people like that as a memory device. Now remember, this angle here, the angle of interest, the angle we're working with, is made from two sides, the hypotenuse and always the adjacent side. So you see, we move the angle, the side, or at least the label of the side, moves as well. What remains is the opposite side. Alright, so if you're faced with triangles to work with and are very careful with the angle we are working with and then labeling the sides, this is really one step closer to helping you be very successful in this trigonometry section. So this was the labeling of the sides. The next is this thing called SOHCAHTOA, which we can use in grade 9 and grade 10. We're going to update it later on in grade 12, but That's good for now. It'll get us going on this topic, and then you can handle the change later on. So, what I'd like to remind you is that we get from each triangle 1, 2, 3, 4, 5, 6 trig functions. And we listed them the other day, or in the earlier video. We had sine, cosine, tangent, and then we had cosecant, secant, and cotangent. And what was also mentioned is that each of these are going to match up with one of the fractions that are created from the sides. All right? That's one fraction for the side. That's another one. Just flip it upside down. All right? This is another one. This is another one. And what's the last one? We got 1, 3, 2, 3, 1, 2. 1, 2, 2, 1. So you see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. They get attached, they get labeled, or connected rather. And then we have the name for a particular fraction. Now, first of all, we're not going to use all 6 right now. We're going to use only sine, cosine, and tangent. And we're not going to use 1, 2, 3 either. What we're going to use are the labels that we just worked on. The labels that we have are the hypotenuse, the adjacent side, and the opposite side. Now, what I'd like you to notice is that, each of these words start with a letter. Hypotenuse starts with H, adjacent starts with A, and opposite starts with O. Next, I'd like you to notice in the fractions that there is a top and that there is a bottom. 3 on top, of course, 1 on the bottom. 2 on top, of course, 3 on the bottom. Right? Lastly, we've got the first letters, highlighting the fact that on a fraction there's a top and a bottom. And then lastly, we have the trig functions that we're going to work with. And those will be sine, cosine, and tangent only to begin with. So, what do these 1, 2, 3 things have to do with SOHCAHTOA? Well, there's a lot of good info in here. And here's how it works. The S, that's for sine. The next letter is the top of the fraction. And then the next letter is the bottom of the fraction. So I could back it up a bit, actually. I said this is sine, it's 2 for S, but this is the trig function you got. So the trig, the top, and the bottom. So for sine, that fraction is going to be the opposite side divided by the hypotenuse. When? Always. And remember, these are going to depend on the angle that we are working with, just like we talked about when we were labeling. Okay, so sine is always going to be the opposite over the hypotenuse. C, that stands for cosine. What letter is first? What letter is next? That's the top. So that's going to be adjacent. What's on the bottom? Hypotenuse. H. When? Always. Okay, this is the name. You have a name, Your cat has a name. These fractions have names. Opposite over hypotenuse, the name is sine. Adjacent over hypotenuse, the name is cosine. Sine cos for short, as we normally do with names. Lastly, tangent, TOA. I'm going to squeeze it in here. A little messy, but don't forget, all the information is there. Right? So T for tangent. The next letter is O for the top. Opposite. The bottom is A for adjacent. Okay, so the name for this fraction of opposite being on top of adjacent, the name for this fraction is tangent. When? Always. All right. So, in conclusion for this part 2 of the intro, second part, the last part actually. Okay, what we talked about labeling the triangles, and it's super important that you gotta keep track of where the angle of interest is, as we called it, or the angle we're working with. Sort of jumped around with that a little bit. Right? So if this is the angle up here, then remember the two sides making this angle are the hypotenuse and the adjacent side. The remaining side is the opposite one. Lastly, how do these all fit together? This cute little trick of SOHCAHTOA. Again, good for now, updated later on with X's and Y's and R's and stuff. Good for now. The first letter is for the trig, the name of the fraction. The second letter shows what is on the top, that is, what side is on the top. And then the third letter describes what side is on the bottom. From this we get sine. It's going to be the name for opposite over hypotenuse. Cosine is going to be the name for adjacent over hypotenuse. Tangent is the name for opposite over adjacent. Alright, so with these two pieces in mind, what we can do is continue on with the next video and actually show how to use them to solve two different types of problems. One, finding the length of the side, which is going to be useful for building your house, analyzing circuits, different sort of things. And the second thing is going to be not just calculating or measuring the sides, but finding angles as well. All right, thank you for today. Looking forward to seeing you next time.